Hi everyone, welcome to the e-lesson and learning platform of Salwan Public School, Mayur Bihar. So the first unit of class 11 physics is physical world and measurement. Some learning objectives are what is physics, types of quantities, classification of physical quantity, unit of physical quantity, measuring process, different system of units for measurement of large distance. First of all, let us discuss about what is physics. Physics is a branch of science which deals with the nature and the natural physical phenomena around us. Physics is such an important branch of science that without the knowledge of physics, other branches of science cannot make any progress. So physics is related with other subjects like mathematics, biology, geology, astronomy, and so on. Now let us discuss about the basic points of this unit. So first let us take types of quantity. Types of quantity is divided into two types. One is the physical quantity and another is the non-physical quantity. So physical quantity is the quantity which can be measured directly or indirectly. Say for example, mass of the body, length of an object or time of an event, etc. And non-physical quantity are the quantity which cannot be measured. For example, all kind of feelings like love, anger, etc. that we cannot measure. So they are the non-physical quantity. Now this physical quantity is classified as fundamental quantity and derived quantity. So what is fundamental quantity? A physical quantity which does not depend on any other physical quantity for its measurement or cannot resolve further are called fundamental quantity and its unit is called fundamental unit. For example, mass, length and the time, etc. So here, let us take a fundamental quantity mass and its SI unit is kg. So kg is the fundamental unit of the fundamental quantity mass. Next is derived quantity. Any physical quantity which can be expressed in terms of fundamental quantities are called derived quantities and its unit is called derived unit. Some examples are speed, velocity, force, acceleration, and you can say momentum, energy, and so on. Now let us discuss one example here, speed. So speed is given as distance upon time. Distance means length, right? So we can write speed as length upon time. So this length and the time are the fundamental quantity. Therefore, speed is the derived quantity which can be expressed in terms of fundamental quantities like length and the time. Now, this length has SI unit meter and time has SI unit second. Therefore, the SI unit of speed is meter per second. So this meter per second is the derived unit and speed is the derived quantity. Now let us talk about unit. The standard measure which expresses any physical quantity is called a unit, which provide the exact meaning to the measurement made. For example, if we want to find out the area of a square box and it is given that area of a square box is 12 meters square. Here this meter square is called unit of area. Now what is measuring process? While going from one system of unit to another system of unit, value of physical quantity never changes. For example, let us take a physical quantity Q, which is given as NU, where N is the numerical value and U is the related unit. So in another system of unit, we can write this physical quantity Q as N1U1. So from this equation 1 and 2, we are getting NU is equal to N1U1. That means NU is equal to constant. So from this relation, we know that n is inversely proportional to unit. What does it mean? Smaller the unit of physical quantity, larger will be the numerical value of the physical quantity and vice versa. Now, different system of units. We have MK system of unit, CGS system of unit, and APS system of unit. So this M stands here, meter, and K stands for kilogram, and S stands for second. That means the length of a body is measured in meter, and the mass is measured in kilogram, and time is measured in second in MKS system. Similarly for CGS and the APS system. Next is International System of Units or SI unit. So International System of Unit is the internationally accepted unit, and these units were introduced by the General Conference of Weight and Measures in 1960, and this system is a modified form of MKS system and hence also known as the rationalized MKS system. Now we have 7 important fundamental quantities and their unit are also given here. And 7 fundamental quantities are mass, length, time, current, temperature, luminous intensity, amount of substance. And their fundamental unit along with the symbol are given here. Apart from these 7 fundamental quantities, we have 2 supplementary fundamental quantity. One is the plane angle, which is 2-dimensional angle, and another is the solid angle, which is 3-dimensional. And the fundamental unit of this plane angle is radian and that of the solid angle is steradian. Now let us discuss plane angle and the solid angle in details. Plane angle is the angle between two intersecting straight lines measured in the plane of the same line as in the triangle, square and the circle, etc. It is a dimensionless physical quantity measured in either degree or radian. For example, here in the figure, we are taking a small section of arc ds. An angle subtended at the center of the circle is d theta and the radius of the circle is given as r. Then we can find the plane angle as d theta is equal to ds by r. So why we are using this d here? Because it denotes that the arc we are taking here is very small and angle subtended here is also very small. Now if we take ds is equal to 1 unit and the radius r is equal to 1 unit, then plane angle d theta will be radian because the unit of ds and the r are cancel out each other and d theta, that means the plane angle is a dimensionless quantity. Next is the solid angle. It is the 3-dimensional angle subtended by any object at a certain point in 3D space like cone, sphere and cube. Here in the example, we are taking a small cross section of a sphere dA and angle subtended for this cross section at the center is d omega. Then we can find out the solid angle by using the formula dA divided by r square. So here in this case also, if we consider dA is equal to 1 unit and r is equal to 1 unit, then solid angle d omega is equal to steradian because this dA and r square has the same dimension and they cancel out each other. So this solid angle is a dimensionless quantity. Now let us move on to the units for measurement of the last distance. So if we want to measure the distance between the two towns, then we can measure this in terms of kilometer or miles. Or if we want to measure the length of the pencil, then we can measure in by using the centimeter scale. But if we want to measure the distance between the two stars or the distance between the sun and the earth, then we need to use a bigger unit. So one of the bigger unit for measuring a larger distance is the astronomical unit. It is the mean distance between the center of the earth and the center of the sun. So here in the figure, the earth revolves around the sun and the orbit of the earth around the sun is not a perfect circle and it is elliptical path, right? So in the definition of the astronomical unit, we are using mean distance or average distance. Now there is a relation between this astronomical unit and the meter, which is 1 astronomical unit is equal to 1.5 into 10 to the power 11 meter. So next larger unit for measuring the large distance is light year. Light year is the distance traveled by the light in 1 year. And from the definition, light year is the distance traveled by the light and distance is equal to speed into time. And speed of the light in air or vacuum is 3 into 10 to the power 8 meter per second. And the time is given as 1 year. So we are going to convert this 1 year in terms of second. For this, we need to multiply by 365 into 24 into 60 into 60. Now the second of time and that of the second at the denominator of the speed cancel out each other, and 1 light year comes out to be 9.46 into 10 to the power 15 meter. Next, move on to another unit for measuring the larger distance, which is the parsec or per electric second, or in abbreviated form we can write par. So it is the distance at which an arc of length equal to 1 astronomical unit subtend an angle of 1 second. So here in the figure, the average distance between the sun and the earth is 1 astronomical unit that we have already done. And angle subtend here, let us take this as 1 second or 1 arc second, and this distance or radius is 1 parsec. Now let us use a simple formula for finding the plane angle, that theta is equal to arc upon radius. So here from the figure we know that angle theta is given as 1 second and that of the arc is 1 astronomical unit, and we know that this distance is 1 parsec, which is the radius. So we need to find out 1 parsec, therefore this 1 second will be come at the denominator. So this 1 will double dash indicate for second. And now next is we need to convert this second in terms of radian. For this we need to use the important not given here. So by using all this we can convert second into radian. So after calculation by putting the value of pi as 3.14, we have 3.1 into 10 to the power 16 meter. So this is the relation between parsec and the meter. Now I'm giving you some assignment related with the topic that we have just discussed now. Hope you can easily do it. So maintain a separate register for physics and make a class note and complete this assignment. When the school open, I will check all your assignment. Thank you so much. Have a nice day.